Hi there. Hey, today we're going to take a look at scale drawings and some conversions here. So when we talk about scale and scale drawing, an example is when you take a smaller object and you're going to be enlarging it to be a larger object. Might be maybe perhaps if you're looking at like model cars or something like that, or a model airplane. You might have the model, which is a little bit smaller than the original or the actual model of the actual airplane or car you're looking at there. And with a scale drawing, you're taking one measurement and you are using what's called a scale factor to then change one to the other. So if I'm usually going from a small to a larger object here, I'm going to have short SF, a scale factor that's greater than 1. Because if this number here, let's say the top of this car had a measurement of 1, then the measurement up here is going to be something larger than 1. It might be something more like 10, or maybe it's even 100. If we're talking about maybe inches long, I don't know. This is a model car. It's 1 inch long, and this is 100 inches long. And so I'd have a scale factor that's larger than 1, going from small to large. If I'm going from a large object to a smaller object, then I'm going to have a scale factor that's less than 1. Right? And that's going to be reducing the size that it is. So that scale factor is a number we use to multiply one value to find another value. And we're always going to be multiplying. Okay? Now when we're multiplying sometimes, again, if we're going larger than 1, that's going to be a number like, again, greater than 1 is going to be anything like, it could be 1, it could be 5, it could be 100. But if it's less than 1, at that point we're talking about scale factors that are going to be maybe in fraction size. Maybe it's a half, right? So it could be like if this was 100 and the scale factor is a half, then it's 100 times 1/2 to end up with 50 over here. So you're looking at fractional things in that regard there. So maybe 1/2, maybe an 1/8, maybe it's a decimal, maybe it's 0.25 is the scale factor. Okay, so that's what we're going to be looking at first of all, scale factoring. So let's take a look here at a triangle that I drew. And triangle here we have a base of 4, a height of 5, and a hypotenuse of 6.5. Now we're going to refer to this one as our original for now. That's what we're going to do. So this is our original one. And so our original one happens to be a 4, 5, 6.4 triangle. Now I made two copies of this one here. We have a copy A and a copy B. We can tell with copy A that it's definitely going to be a lot smaller, right? So because it's going from a large one to a smaller one, this should have a scale factor that is less than 1. Whereas this one over here, it's a larger copy, will have a scale factor that would be greater than 1. Now, because I don't have any numbers on these triangles yet, we don't know what the scale factor is going to be. But I've left that blank just for now, just to help us understand a couple things. So my original one, if I make it larger, scale factor is going to be multiplying by a number bigger than 1. If I make it smaller, then the scale factor will mean I multiply the value of the original times a fractional number, or a number less than 1, to find what that value is going to be. Let's take a look at going from the original to a larger copy first of all. Let's say that I had a value here of 8 and I had a value here of 10. When we take a look at what's happening, the bases are going to be the same. Again, I want to compare the same parts to parts. So I'm going to compare this base to this base here, and maybe I compare this leg, this height right here, to that leg there. And then of course we have our hypotenuse. Yellow is not too great of a color for me today. Let's use orange. We have a hypotenuse and a hypotenuse. So when I take a look at this here, what I notice is that the 4 has to compare to the 8. So the 4 to the 8. And what I ask myself here, because a scale factor is again multiplying, is I ask myself, what number 4 times what number, or what scale factor is going to give me a solution of 8. So what scale factor, and again because we're going from a smaller to a larger, what number greater than 1 can I multiply by 4 to end up with an answer of 8? Sometimes it's pretty obvious. Sometimes you can say, well, that's just simply going to be a scale factor of times 2, because 4 times 2 is 8. If I didn't know, I could work out a solution where I divide both sides by 4, and that will eliminate the 4, and I would say the scale factor is equal to 8 divided by 4, which is 2. Now knowing that's the case, If this are two exact copies of the triangles, then I can verify that by saying, well, what is 5 times 2? Well, 5 times 2 is 10. So I now know that the scale factor between these two items is a scale factor equals 2, meaning that if this one is 1, then this is times 2. Sometimes you might write that as a 1 to 2, meaning this is my original and this is my copy. All right, it's 2 times larger. Knowing this here, can we figure out what value belongs right here on the orange side? Sure. What I want to do is take the value of the original, okay, 6.4, and multiply it by the scale factor. Let's do it like this. Let me erase this real quick. What I'm going to do is I'm going to make my original times the scale factor is going to let me know how large the copy is. So my original in this case is 6.4. My scale factor is times 2. And so that's going to make my copy 6.4 times 2, which is equal to 12.8. So I can find the value of that line, or that hypotenuse of triangle, just like so. Okay, so that's how we find a scale factor using some common elements, and we can also use a scale factor to find unknown values. Let's take a look at what happens when we go from large to small. Again, our scale factor is going to be something smaller than what we had before. So I'm going to go ahead and put some values here. We're going to put a 2 right there, and then I'm going to also put a, let's do a 2.5 over here. Now again, my sides are going to be copies, so that's my base, and here's my height, and then my hypotenuse is orange. Okay, so I want to take a look and say, well, what's happening? What am I multiplying by to go from 4 to 2? Right, so same question like last time. So 4 times what scale factor equals 2? To solve that, I can divide both sides by 4. So the 4 is crossed out, and my scale factor equals 2/4, which is the same as 1/2. So in this case here, my scale factor is actually equal to 1 over 1/2, which means if I think about my original compared to my copy, if the original is 1, the copy is 1/2. So let's see if that's true. All right, well, what is 4 times 1/2? So look at 4 times 1/2. 4 times 1/2 equals 4 over 2, which equals 2. So indeed, the 4 times 1/2 equals 2. How about the 5 again? What is 5 times 1/2? Well, 5 times 1/2 equals 5 over 2, which then becomes 2.5, or written as a decimal, it's 2.5. So our scale factor is less than 1, means we multiply by a fraction or sometimes a decimal. Can we, again, find this missing value for this problem, that part? Sure we can. Let's use our same setup as we did before. We're going to use our original times the scale factor to find the value of the copy. So our original here is, again, 6.4. The scale factor we're going to use is this one here. It's 1 to 1/2. So we're going to multiply that by 1/2, and then we're going to find out our copy. Now you might be a little stuck here thinking, well, I have a decimal and I have a fraction. What am I going to do with that? You could either convert the decimal into a fraction or convert the fraction into a decimal. For this problem, I'm going to go ahead and convert the fraction into a decimal because 1/2 is the same as 0.5. Now, when I multiply that out, 6.4 times 0.5, I get 3.2. So indeed, we can find out what that value is going to be. All right, so we have a scale factor working for making a copy larger, and a scale factor making a copy smaller. One common place you'll often see scale factors is on maps. Okay, and you'll see usually a scale is provided, and a scale might say something like 1 inch equals 5 miles. Because on a map, you can't make a map that's actually going to show you 5 real miles, so you scale the reality back to match your copy. So in this case here, this might be the map, and this is going to be the real world, reality. But you can use these kind of scales or these conversions then to let you figure out if you had a map, and on the map there was a distance of one inch there, 1 inch there, and 1 inch there. You could say if this was all 1 inch, 1 inch, 1 inch, how many miles would that be? Well, 1 inch equals 5 miles. So really this is the same as 5 miles, 5 miles, 5 miles. So we would actually have a total of 15 miles is the same as 3, in this case here, 3 inches. So 3 inches goes to 15 miles, or 1 inch, like we said, goes to 5 miles. Okay, so that's how scales work there. So let's take a look at some other ones just to get some practice together before we move on. Okay, so let's take a look at this first triangle. Let's first of all ask, what is the scale factor here? Meaning, if I'm going from here to here, what am I multiplying the 3 times what scale factor to get to 9? And again, sometimes it's pretty clear you can tell what that is. I'll write this here. Let's do 3 times scale factor equals 9. I'm going to divide both sides by 3. So that reduces there. My scale factor equals 9 divided by 3 is 3. So my scale factor is 3. And knowing the scale factor is 3, can I find the value of x? Sure I can. I'm going from, oops, sorry, I circled the wrong one. Be careful there. Whoops. I'm looking at, I want to make sure it's the right height here. We can see x is on this leg right there, which means I want to compare it to this leg right there. So I do my original times the scale factor equals the copy, which in this case is x. So my original is 4. My scale factor we said was 3. And 4 times 3 is equal to x. And 4 times 3 is 12. So the missing value there is going to be 12. So you can see how we can use one triangle and answer a couple different questions. We can find out, if we know it's a copy, we can find out that what the scale factor is going to be, and we can also solve for unknown values. Let's look at one more. In this case, it says if the scale factor is 1 to 3.5, what is the value of x? So a couple things we can tell already. We can see that the original compared to the copy, the original is smaller than the copy. The copy is going to be 3.5 times larger than the original. Remember, whenever it is the scale factor is greater than 1, that means the size is going to be increasing here. So we know that if we started at 5, the scale factor is going to be increasing by 3.5 times larger to get to x. It's going to be a larger value of x. So don't worry about the picture so much, right? We're going to have a scale factor that's larger. So how do we solve that? Again, we're going to do our original times the scale factor to find out what the length of the copy is going to be. Our original in this case was 5. Our scale factor is 3.5, and that's going to equal the value of our copy, which in this case is x. I could use 5 times 3.5. I can write that as a decimal if I chose to. A lot of you like decimals, I know. So we do 5 times 3.5, and that's going to equal, in our case here, still x. And 5 times 3.5 is equal to 17.5 equals x. 17.5. And I think the only thing to keep in mind here is that sometimes your answers, if you're doing multiple choice types of tests, sometimes you may have a fractional answer and not a decimal answer. So just do keep that in mind. You might, this is a little bonus thing here, if I had 5 times 3.5 and I wanted to write it as a fraction, I would need to convert this into an improper fraction. So 3 times 2 is 6, plus 1 is 7. So I actually have 7 halves here. And then I do 5, which is 5 over 1. 5 times 7 is 35. Over 1 times 2 is 2. So now I have an improper fraction there. So if I want to make it a mixed number, I would say, well, how many 2's are in 35? And I have 1. Let me subtract. 15, we have 7, which is 14, the remainder of 1. So this tells me that this number as a mixed number is going to be 17. I got that from right there. How many are left over becomes my numerator, and what I'm dividing by stays my denominator. So I have 17.5 that way as well. All right, now we're gonna have you try one real quick, and then let's see how this goes. So here's your first one. I want you to go ahead and give this one a try. So pause your video right here and give that one a shot, and we'll come back and check it together in just a second. All right, so for this first one here, we had two rectangles, rectangle A, rectangle B. We had some sides here that were provided for us. We have this length here of 2, which corresponded to length 8 over there. We had this length of a 4 and this length here of a 16 for these two rectangles. And it asks, what's the scale factor between rectangle A and rectangle B? Meaning, what does it take to go from 4 to 16 times what scale factor does it take to go there? And you can again write that out as 4 times the scale factor is going to equal 16, and then solve for the scale factor. We divide both sides by 4, and our scale factor equals 16 divided by 4, which is 4. So the scale factor is 4. You'd probably write that down as something like 1 to 4. You might write it as 1 to 4. All right, these are all just fine. It's a way of showing that this one is 4 times larger than this one over here. Okay, that's the first one. Let's try another one here. So here it is here. All right, I'm gonna put it there. Go ahead and pause your video, and why don't you work on this one for just a couple seconds or a couple minutes. All right, so here we go. If the scale factor between triangle A and triangle B is 1 to 5 1/3, what is the value of x? So again, what I can see is that I'm comparing this line to this line. We're saying that there is a scale factor, so these are copies here. Okay, and the scale factor is 1 to 5 1/3, meaning that to go from A to B, we're multiplying it by the scale factor, and in this case here we're multiplying it by 5 1/3. So we're going to take the value of the original times the scale factor to give us our copy, just like we did before. Our original was 4, our scale factor is 5 1/3, and that's going to give us the value of x. So what I'm going to go ahead and do, I'm going to make these turn this into an improper fraction. I'm going to do that because it's a third, and I don't want to have a run-on decimal of 5.3333. I could, but it's just going to be a little silly. So I'm going to make this 4 times, let's make this improper, 5 times 3 is 15, 15 plus 1 is 16, so we actually have 16 over 3. We're going to multiply straight across, this is 4 over 1, so 4 times 16 is 64, and 1 times 3 is 3. So I end up with 64 thirds written as an improper fraction there. If I want to write that as a mixed number, I can do 3 divided by 64. 3 goes into 6 2 times. 2 times 3 is 6. Bring down my 4. 3 goes into 4 one time. So we have 3 there, and we have 1 left over. So I actually have 21 1/3. And that's another way of looking at that there. Okay, so that's a little practice with some scale factors. Now let's use this information here and look at one other concept that is semi-related but a little different as well. That does come up when you're looking at scaling factors, and that is the idea of conversions. And let's begin with this situation. Consider this situation. You need 24 inches of wire for a project, but the store sells wire by centimeters, not inches. Now, knowing that 1 inch equals 2.54 centimeters, how many centimeters of wire do you need? So here's our problem. We want to buy some wire, right? We're going to go buy some wire for some kind of project. And I need 24 inches of this. But when I go to the store, it's on sale, or whatever's going to be on the tag, and it's sold by centimeters. So I need to buy a certain number of centimeters, but I don't want to buy too much or too little. So I need to convert what I need, the inches, into what I can buy, which is centimeters. Okay? Now, luckily, they gave us the scale factor. Okay? So think of it this way here. It's like, in this case here, I want to convert my inches times the scale factor that's provided for me here in order to give me the centimeters that I want to purchase. Okay? So inches times something is going to get me over centimeters. And in this case here, we know that we have 24 inches that we're going to work with, and we're going to use a scale factor in order to come up with centimeters. I'm going to put inches right there. I'm going to get a little more space here, just so I make a little more space for you guys. So 24 inches times something to give me centimeters. So this scale factor is our conversion to convert inches to centimeters. So to make this work, what we're going to do is we're going to take a look at what we have. We have 2.54 centimeters and 1 inch. Think of this like a fraction here, right? I want to make sure that when I multiply this together, right, that I'm left with just the term centimeters, which means I want to put 1 inch on the bottom, and I'm going to put 2.54 centimeters on the top. Because when I multiply that together, what do I end up with? Well, I end up with 24 inches times 2.54 centimeters all over 1 times 1 inch over 1 inch equals whatever I'm looking for. And in doing that, what can I cancel out? I can cancel out the term inches, and all I'm left with then is centimeters. So now I'm going to multiply 24 times 2.54. When I multiply 24 times 2.54, I end up with 60.96, and all that remains for my terms is centimeters. So I took what I knew, 24 inches of wire, I multiplied it by the scale factor provided, 1 inch equals 2.54 centimeters, to find out how many centimeters are in 24 inches of wire. So when I go to the store, I would go out and measure 60.96 centimeters and buy that many, and I'd have 24 inches exactly. Alright, now I think what's tricky about conversion sometimes is sometimes you might know the conversion, or might call it a rate sometimes there, and sometimes you don't. So let's take a look at a few common conversions that you might see from time to time, just to make sure you at least know how to do it, but just know that these are also things you can probably look up as well. So if you get stuck at some point on some conversion, you can probably find the conversion in Google someplace to see what the conversion is going to be. But a basic conversion you probably worked with before is 12 inches is the same as 1 foot. So when I solve conversions I can solve them also by using what's called a proportion, which in our last problem we didn't use proportions. We just set it up this way and said, well, let's make it equal to each other. And we did it an equation kind of way. This was an equation way of solving it. Let's solve it with proportions. Here's how this works. To solve with a proportion, I take the scale factor that's provided for me here, and I set it up to say, well, I know that there are 12 inches in 1 foot. Now think of it like this. I have a couple terms, right? I have inches, right? And I have feet, or a foot. I want to make sure that these match up the right way. So here are 12 inches, and here is 1 foot, right? I'm going to set that equal to another fraction, and this is going to be a proportion, which means in order for this to work, I need to make a proportional relationship so this works out well. So I know that 12 inches are in 1 foot. I want to find out how many inches, which I don't know yet, so we can call that number x, are in 8 feet. And in this case here, the number we're going to put down here is going to be 8 feet. And the reason I'm putting the feet down there is because it lines up. Pink, pink, green, green, we're good to go. So to rewrite this nicely for you, I have 12 inches and 1 foot equals x inches and 8 feet. To solve this here, I can use cross products, which means I can essentially multiply 8 times 12, and 8 times 12 is going to be equal to 112, and that's going to be equal to 1 times x, which is x. So our value for x, and x stood for inches, how many inches are in 8 feet, is going to be 112. And that's solving with proportions or cross products there. And you can do that for any basic type of measurement. If you know the conversion scale factor or rate there, you can use that conversion then to set up a proportional relationship. But make sure that your terms match. Numerator, numerator, denominator, denominator. It's just best that they match. There's other ways to set them up, but that's just a nice way of doing that there. Okay, let's try another one. How many kilometers are in 300 meters? Well, we know that there are 1,000 meters in 1 kilometer. So we could set this up like this. 1 kilometer is equivalent to 1,000 meters. I want to know how many kilometers, so x kilometers, are in 300 meters. Okay, I'm going to use some cross products here. So I have 300, and if you want to keep your labels there, you could, but I don't need to really. So 300 times 1 is 300, equals 1,000 times x is 1,000x. And this is the point where you might think, well, why am I doing that? Because now what I have to do, I have to get the x by itself. And I'm going to divide both sides by 1,000. So I have 300 over 1,000 equals x. Which, if you think about it, if I just multiplied that and left it up there, what would I have? I'd have 300 over 1,000 equals x. But that's okay. We wanted to show you at least the process there. So now, to reduce this here, because they both end with zeros, I can eliminate a 0 there, and I can eliminate a 0 there. So I'm really left with 3/10 equals x. So how many kilometers are in 300 meters? Well, 3/10 of a kilometer. Or I could write it as a decimal and do 0.3 kilometers. Either one would be just fine. But again, I'm using a proportional relationship and cross products to solve what that's going to look like. Okay, let's have you try one of these on your own, and it'll be our last thing for the day. So here we go. Give this one a try. You know that there are 4 quarts in 1 gallon. How many quarts are in 5 gallons? I'm going to pause here for you, give it a moment, and then come back and check in just a second. Alright, how many quarts are in 5 gallons? Well, let's start with what we know. We know that there are 4 quarts in 1 gallon, and we're going to set the proportional relationship. I want to know how many quarts, so x, quarts on top, are in 5 gallons, gallons on the bottom, right? And we can use cross products. 4 times 5 is 20, and that's going to equal x times 1, which is x. So how many quarts are in 5 gallons? There are 20 quarts in 5 gallons. Alright, that's it for today. Have a great day, and we'll see you next time.